Okay, so today I will show you my homework chapter 7.3 to you. It's about Siemens PUC. Okay, you can see the topic of this research is Siemens PUC and HMI dual screen for digital counter display experiment analyze. Uh, the okay, so let's see the content. Behave these 8 parts. Such as experiment objective, HMI design, experiment significance, implementation process, hardware connection, key consideration, code explanation, and conclusion. Okay, so you can see the experiment objectives. Master PLC multi-language programming, professionally in LD for logic control and LCL for numerical operations, understanding collaborative logic, master HMI multi-screen interaction design, learn multi-screen switching, button control, and numerical display binding for uh, visualized interaction, and understand PLC HMI data interaction, gas address mapping for two-way communication, and implement complete counting function. Design 0 to 9999 link counting logic with start and stop control and HMI result display, and build a complete industrial control link. Master the full process from hardware writing, programming, configuration to joint debugging, and let's see the industrial application value. The foundation prototype for counting system, a fundamental prototype for industrial counting system, extendable to production line product counting, equipment and statics and output counting. A classical introduction case for PUC plus HMI joint development, and practical HMI design logic. Through screen design mirrors real-world industrial HMI usage. Screen for start-stop control, and screen 2 for results display. Mm. Separating operation from display enhance interaction safety and convenience. Okay, the learning and skill enhancement. Programming skills. Master 2 core Siemens PLC programming language. LD for intuitive logic, and SSCL for efficient computation to meet diverse control scenario need. The system thinking establish a complete understanding of hardware, software, HMI, comprehend the full process from requirement analysis to system implementation in industrial control, and engineering practice. Acquire practical skills in variable definition, address mapping, screen configuration, and joint debugging, laying a solid foundation for complete automation project. And the hardware list, you can see the PUC controller, HMI, touch panel, communication cable, power supply, and the physical button. The function is on the list. And the writing step. Power writing, connect 24 volt DC power. PUC L plus positive, M negative. Power HMI with same supply. And communication writing. Connect Profinet to Ethernet, ensure some network segments. And the physical button start to uh, 0.0, stop to 0.1. Common terminal to 24 volts DC negative. Power down check, verify run and power lights are on. and confirm detection in TIA portal with normal communication. Okay, so the variable definition POC side, you can see the data type, address, and the function. The SCL code explanation. The start-stop control logic, pressing star set counting enable to true, enable counting, and press the stop reset count enable to false, pausing the process. And the core counting logic, alter if ensure counting only runs when enabled, inner if increment data up to 9,999 at 1 million, data reset to 0, creating a 4 digital cycle. And the leader diagram explanation, you can see the start and stop control and the core counting logic. And you can also see the leader diagram logic schematic in the right. The LD implementation mirrors the SEO logic using set reset for state control and add move for select counting, achieving the same functional results with a graphical representation. Okay, so you can see the HMI screen design. The screen 1 operational start button, stop button, and switch, and screen 2 display, a 4 digital display, format, and back button. Okay, so the HMI configuration step: establish PUC HMI connection, import variables, create screen, configure events, set display format, and simulation test. And implementation process. First, we preparation. When check the power, check the hardware writing, then the PUC development, HMI development, joint debugging, and optimization. So the key consideration and conclusion, you can see variable consistencies. Ensure PUC and HMI variables share identical address and data types. DB block optimization. Disabled an optimized block as for this one to allow absolute addressing, and the counting speed using a timer to control cycle and prevent excessively fast counting in practice, and button mode using momentary mode to start and stop to avoid miscalculation and leading zeros. Okay, that's all about Siemens PLC. Thank you.